We're going to talk about programming languages today. So Rust, Zig, Carbon, Hype, Hope, or Hell. This is the question what we're going to answer, or maybe not today. We already had, like a nice introduction. But maybe very quickly, I'm a developer. I've been with Thoughtworks for a while. Clearly, my background is in web and cloud world, but it's been like the last 5 years in automotive, where C and C++ is very dominant, and we have to look for alternatives. Let's put it like this. Over to you.
And also it's hard, after this nice introduction, right, to talk a little bit more about me. But thank you. But I believe that we can automatically jump to the motivation, because most of the introduction, I believe that right now you know more about me. But let's talk about what's the motivation of this talk, right? So especially when it comes to embedded development and also software performance application, high performance application, C and C++ are the biggest dog today, right? However, both of them have downsides. And most of the people try to look for another options, right? So the goal for today, for sure, is to talking about Rust, Zig, and Carbon as a candidate alternative when you discuss about what option you have to replace C and also C++. So the goal for today is to talking about the perspective about all of these three, right? The idea is we don't rank, what's the winner here between all of these three languages, not it at all, but get more insights, about the weakness and also the strength for all of them, and also get a better understanding in what situation might be worth to get more close, right? So instead of, again, deep dive the interface or also syntax of each programming language and then compare side by side, we want, for sure, understand the promise, the claim of the languages, right? And also see what each language already is trying to fulfill them. So we hope that at the end of this talk, all of you already understand and also be curious about all these languages and try out more, and also be more familiar, a little bit more with the languages, and get a better understanding about what situation might be worth for you to be more involved and use all of them. And while you certainly have an opinion, we believe that at the end of this talk, you can understand and try to decide for yourself if Rust, Zig, and Carbon is hype, hope, or even hell. So what about Michael to talking about Rust? Let's start with Rust. Okay.
Yeah, let's speak about Rust first. Who has written Rust before? Hands up. That's half. So some of you might know way more than me about Rust. Disclaimer up front, I'm a Rust fanboy, but I'm going to try to be as objective as possible. Just to give a quick overview, Rust started 2006, initiated within Mozilla. The context was to write a new or an experimental browser engine. So we speak more on the system level programming here. The first version of Rust was published like 2015, 1.0. So we are like 8 years in. Current version is, I think, 1.7 something. There was a bit of a shake-up in the Rust programming language in 2019 when Mozilla laid off a bunch of people, and also the core team of Rust was affected. So it was a bit unclear for a few months what the future of Rust is going to look like. However, in 2020, Mozilla and a few other, one of the larger companies founded the Rust Foundation. It's a non-profit organization now, so it looks like the further development of Rust is stable now. As Desiree pointed out, we want to look at what are the claims of the programming language and have a look like how are they doing this. So if I go to the Rust website right now, like it just right in your face, it says these three things, right? We want to ensure, that the software you write is performant, that it's reliable, and we want to ensure a good productivity of development. Yeah, let's see how they're doing this. But before we dig in, I want to highlight something else. I found it interesting that there's this survey or this report from Stack Overflow about programming language and tools and frameworks. And Rust has been for years and years the most loved programming language. The people who use it really, really liked it. But at the same time, if you look at the adoption rate, it was so low, right? And it was also very slow. So that was interesting. The people who use it like it, but not a lot of people use it. This clearly has changed, and I think that's worth mentioning, because I think it was 2020, 2021, like lots of big companies said, oh, we're going to bet on Rust, we're going to include this. Right now you have, in Android 13, you got like 21% of the code is in Rust. Rust is the only language that's the second language inside the Linux kernel, and also Microsoft is adopting Rust for some of the core components in Windows. I couldn't find like details about it, but they are serious about this, right? Let's look at the performance. When it comes to performance, I think there are like different categories, I would say. There are some facts that are more about the language design. So Rust doesn't have a runtime. Rust doesn't have a garbage collection. And the goal is to have all the abstractions at zero cost, right? So by design, the language is quite performant compared to interpret languages or something like this. Then there's another layer that's more when you compile on an optimization level, because not always, but sometimes you can do static dispatching, zero copying things, or inline expansion of function calls, right? That makes it even further. But what's also interesting, I mean, the compiler uses LLVM as a backend, so everything you improve in the LLVM and in the backend will also, then be beneficial for Rust. And then there's a few more fuzzy things that, like, Rust has a very extensive macro system, so you can do lots of things, in compile time, expand, the high-level code into lower things that also ensures performance. And what people always forget, I mean, you can't solve all performance issues with concurrency, but if you can, it's really easy to write concurrent things in Rust. So if that's a lever for you to enhance your performance, that might be interesting. Leaving all the technical details aside, comparing, languages and performance, it's quite hard. A lot of people put lots of time and fun into this. I just looked at some of the results. So here we have, different algorithms implemented in Rust and in C++, and they also did different versions of the implementation. I guess it's fair to say it's on par with C++. There are, things where C++ is faster, there are things where Rust is faster, but I guess it's on a very comparable level. If you would put next to it Java or Python, right, this would be a different magnitude in performance. And also the thing is, performance can be two different things, right? Sometimes I want a programming language where I just write my programs and I want to have a good performance, right? And in Rust, honestly, for most cases, just do the minus release when you build the thing. That does a lot of things, and likely you get a good performance out of your code. However, sometimes you have this situation when you're like, I need this function to be as fast as possible, right? And you really optimize for this. Then there's a book for it, Rust Performance book. I'm not going to go into the details, but there I would say maybe other languages can give you even more freedom to do nasty things to increase the performance. Because that brings us to the next topic. It's a bit cut off. That's probably my fault because I didn't use the template right. When it comes to reliability, there are different concepts that ensure that your software is reliable. Some of them are really on a language level. So it has the concept of ownership and borrowing. You can't have dangling pointers. It just doesn't work. The compiler will hit you in the face and more often than you want, actually. Unfortunately, also there's the concept of lifetime. So sometimes you have to say how long a variable should be in scope or is in scope. Lifetimes are hard. I struggle with them a lot. And then you have a few things that you also find in other languages that are just very modern concepts. You have options and you have results, and this means you can't have null, right? Or you have good pattern matching, and also if you match over an enum, it will tell you, oh, you forgot this case. Maybe you should know that. And then there's error handling and a strong type system. So there are just lots of different concepts in the language that ensure reliability. And the outcome is, well, first of all, there's a certain class of errors that simply can't occur anymore. So it's you have static memory safety that is ensured, and lots of those things just can't happen. But it also, for me, it's like when I really use the strong typing system in Rust and it compiles, it's like, it compiles. It's probably right? Nobody can prove that to you, but you just get a very good confidence in the code. And I promised not to speak so much about automotive, but just for here, in automotive, there's this standard, the MISRA rules. Basically, it's a set of rules that says you should do those things in C++, and then your code is likely to be safe, right? And the way it works, you have a text document with all the rules, and then you have developers who go through these rules one by one and fix the code. And what I found interesting here, 70% of those rules, if you use Rust, don't apply anymore because your code won't compile. And I guess that's a good comparison if you think about the reliability of the language. Or productivity. Few things there. Rust has a good set of tools that come with it or have been developed in the ecosystem, like the build tool, how to install it, support for editors, and it's super boring. It just works, right? I want to cross-compile for a different target. I install it, just one command line, and it just works, unlike other experience I had. I think it's nice for experienced developers that take the time to learn it. Sometimes it can be hard to learn because the language is very minimalistic, uses very short keywords. It has lots of syntax sugar, so you have to learn the idioms to write. That's the Rust way to write it. But I guess if you're over it, then it's really good. As I pointed out earlier, to please the compiler can be hard. Sometimes I even get stuck. Like the compiler says, no, you're not doing this. And then you're like, yeah, okay, you really have to take a step back and write it in a different way because you can't ensure that it's safe in that way. The Rust community is active and growing. I especially want to point out the number of books that are free and that are there. So Rust, by example, the Rust book, the performance book for embedded, it's all free. And I think they're very reasonably good. Pointed out, compiling can be painful not only to please the compiler, but sometimes it's very slow because the language is very minimalistic. You have to use lots of modals. It doesn't even have a data type. It doesn't have serialization, so you have to pull in a module for this. That can make compile times very slow. But you can always get to the point where you can actually TDD, and that's, I guess, the main point about it. It works well with C++ in the sense you have to create bindings if you want to use C++ function calls. That works, I would say, but since you have to create those bindings, if you have the scenario that you develop the C++ side of the system and your Rust system, I guess that can be very painful. I think there are other concepts we hear later where this is more beneficial. To sum it up, I think Rust does successfully what it claims to do. Certain benefits clearly come with the costs. Sometimes it can be compile time, sometimes it can be a bit of nerves when you try to please the compiler. But it clearly also has found its niche, not only in embedded system programming. I think lots of people are writing command line tools in Rust. WebAssembly is also supported by Rust. And for some reason, in the blockchain and crypto world, I mean, if you type in Rust remote developer job, it's going to be crypto, right? It's not my cup of tea, but it's very established there. I found this quote, and I don't know where it came from, so I can't remember, but Rust is a good choice for code that is meant to be around for a while, and I guess this sums it up pretty nicely. let's speak about Zig. You want to come to the center?
Nice. So let's talk about Zig. Just to understand how is the heat map here, raise a hand who already implement or know about Zig, the language. No, it's nice. It's good. Let's talk about a little bit and know more about Zig. So the Zig language, it's good because from Zig we have like 2 different flavors, right? Most of the language is more purely language, right? But from Zig offer you can use as a program language, but also you can use as a tool chain. That is the first big point here, and it's interesting because when you have like these two flavors support you to do much more things, or also use one or the other, but it's a general purpose program language, and also to chain, which support you to build your software much more robust, optional, and reusable. One thing that I'd like to highlight, because most of the time when you mention about robust, we can connect with resilience, right? But here, because it's much more focused in high performance application, the idea of robust is to cover edge case when you deal with memory allocation or much more close with the hardware, critical area. So the robust touch exactly this edge case. Optional because Zig is for performance and high quality software, right? It's a critical area which is critical in, for example, in embedded ecospace or close the operational system, critical space. So it means the performance and also the quality, the high quality, and also reusable because you can use in many space, not only in low level, but the idea is support the high level too. So it increases your area that you can use this program language, right? But one thing that is interesting, this language is pretty new. Less than 1 decade, we have like this program language. And it's interesting because even though, right, 2015, Andrew Kelly created the first Git init, right? And right now, we still don't have the 1.0 version. So if you want a stable version for Zig, we need to wait a little bit more. But it's still promising, right? And at the same time, with so very young, this language, in this year, we have this Stack Overflow survey. This language appears as the third most admired language. It's only behind Rust and Elixir, right? It's calling attention. And the most paid language, and I believe the most paid language because maybe we have few developers, few people with this skill, so it's more paid. But not in the different perspective, we have this is not so much popular. And I believe that when I asked about if you know or use, it's completely connected with these results, right, in terms of popularity. And it's funny because in terms of popularity, Zig is pretty close Prolog and also Fortran, right? So you can measure the level of the popularity. But, okay, right now that is much more understanding. We can understand the purpose of this language. It's interesting to figure out where, which real case scenarios I can use Zig or even see Zig in the real, work in action, right? We have also some cases, public cases that is starting to use Zig as a language or a tool chain. The first is Boom. And Boom is a JavaScript runtime environment, built on top of Zig, which I can say drop in replace Node.js, because Node.js is written in V8 on top of written in C++, right? And Boom is exactly fight exactly to use, instead of use WebKit, JavaScript engine, they are using Zig to fight the performance. And based on the current results that we have, compare Node.js, Deno, and also Boom. Boom seems more performatic. So it's one thing that you need to, as an edge case, that we can see the Zig in action. The second one is the Tiger Beetle. Tiger Beetle is a database, again, a database which it's touch the performance, and also how much the database should be secure and resilient. So Zig also support is built on top of, is part of the core for the Tiger Beetle. But the Tiger Beetle is a database for financial scope, space. And these two user cases much more focused in use Zig as programming language. But also for Uber, use Zig much more in toolchain for the build system and cross-compilation. Later we'll talk more deep, but you can see easily these three big and public cases today, right? Real life use Zig, and Zig is pretty new language, so it's calling much more our attention. So, but why Zig, right? We have so many languages. Go, Rust, Carbon, we have so many languages, why more one? But there is a reason, the Andrew Kelly mentioned about there is a reason, there is a space for Zig. And this question, to answer this question, they mentioned about 4 steps, and we will talk about quickly these 4 steps. The first one, as I mentioned, is the high quality performance. So when you talk about build an application for this space, we really need to have much more control, right, about the memory, how you're locating. Probably you can't use the garbage collector, and you need to have a much more understanding in terms of memory allocation. Use or choose tech stack which give you much more performance, right? And also probably touch the CBI to be more compactable, because maybe you need to build your application in one Rust host and then run this application in a different host. So we need to take care about all these points, and it's the first point very strong when you thinking about in a high-performance software. That is one. The second point is the reason most of the language does not fulfill these needs. We have, for example, Java or Python or another language that sometimes does not support, these principles or these design standards. And then there is a reason we have most of language mainstream and we can use them. Right? If you want to use, probably you face a problem, because you can really support in this, use this, the product, if you choose the wrong tech stack. And then the third step is, okay, since that most of the language does not support me to build, why not C++, right? And then Andrew Kelly mentioned C++ is too much. Maybe it's a lot of things that it's interesting, calling my attention, but sometimes violate some principles, then it's not so much clear, but it's too much. Zig is not the same, going the same way the C++. So no C++, and then we have C, right? Why not C? But the point is C is very good, but C already have some preprocessor, macros, and we have some problems if you don't take care how you are using all these features, right, that the language provide. Because sometimes you can make a mistake using it, and then you can, again, face problem. You know that most of we have a statistic that is proving that we have vulnerability, right? And also a lot of problems with buffer overflow, and maybe C and C++ is everywhere, and also bugs is everywhere too. So it's one thing is related with the other, but it's easy to make a mistake. So here, for example, you can see example of a simple code, right? It's one possible, when I mention about easy to make a mistake is, we have a simple if statement here, right? So if it's true, let's print hello, and if it's false, that idea is the other flow. The point is, when you use like a macro, it's possible in the line, for example, 3 until 6, you can undef the true and false. It means the way that we use, right, this Boolean, and then we can adjust, and change and the true linked with 0. I mean the opposite, right? You can do it. It's possible to do, and that is the reason I mentioned it's easy to make a mistake, right? For sure, here it's pretty clear, and I believe that we won't implement exactly in this way, right? It's clear that it's wrong. But when we come up with a business logic, a business implementation, it's easy to guide you to commit phase and have like this kind of mistake. And then it's one thing that I mentioned, it's wrong, you can easily make a mistake. So at the end, when you change the true, associate true with 0, when we execute this code, the result is, oh no, right? Because it's in the way that we implemented, but it's not what we expected. So that is the reason we have Zig. Zig is here much more to fulfill is designed in 3 different perspectives, as a simple language, in compile time, and also the build system as a tool chain. So these 3 mainstream areas is the strong and the differentiation when you're thinking about Zig. So let's talk very quick about this, the idea is to be a simple language. And simple language for Zig is much more than an easy language or syntax. It's more than it. The idea is to fulfill the whole developer experience, right, much more than a syntax. So here we have like a simple hello world, because every time that we start a language, for sure, the first contact with the language is hello world, right? So here, the idea for Zig is to be, again, the replace for C, because Rust is more the direction and connection with C++, but here the idea is to be a C without problems. And here we have a simple hello world. With the first line, you can see we call as a built-in. You can see the import is the way that you can access the standard library, and from the standard library, you can access many interfaces. For example, you can access or have like your testing framework, or debug your application, or log, or even parse. So we have a lot of packages, a lot of functionalities that you can use, and the library and the Zig provide you for you everything. And then you have like the main, right, the entry, like the main function, not so much different. And then you have like the try, and then you can print. Nothing so much different, but one thing that I like to highlight is, if you only download, access ziglang.org/download, you can download the tarball, right, very minimalist, and then you have Zig. You don't need to spend so many time, to configure or to deal with CMake or C or Ninja or all these kind of things that probably you face when you start with C, because C is not only C, right? It's the whole infrastructure with C, and then there you have a problem. For Zig, it's completely different. It's very smooth. Download, then you have like the CLI, and then you can build, compile, or cross-compilation. Everything is easy. So also we have here a simple way to control the memory in the line 4, right, which give you access to understand, access the interface to control different levels or different ways you control the memory. And then you defer, and then you do whatever you want to do. You don't change anything in terms of control the memory. For sure, it's a different way, because for C, we have like malloc, right, or this kind of way. But for C, for Zig is a different way, but you need to control the memory, but give you much more way, right, to do what you want to do, instead of using a library, a client that you don't know what is happening behind, and you don't know what's the technique, right, to control better way your memory allocation. The second point for Zig is the compile time, comp time. The comp time, because Zig, the way that Zig operates, give you much more control in what you are implementing in the compile time. So Zig is a compile-centric feature for Zig. It means that anticipate a lot of checks, a lot of validations during the compile time. So that is one point that Zig mentioned. Zig give you visibility about the error that you have. So, and also accelerate the performance, be more performative, because they don't allow you to do things in the wrong way. And everything is completely during the compile time and not during the runtime. So they are anticipated. And here we have, for example, during the compile time, we have like the generics. For example, here we have like a test, right, where you are validating the range and passing a type. And during the compile time, you're using like during the compile time, you have like the function, the implementation for the function range, where you pass the keyword comp time is the way that the compiler knows that they need to, during the compile time, validate everything. And here they are validating, getting this type, right, this type that I'm passing. And during this compilation, I also can check, validate how I'm implementing the logic for this generic. That is very simple, but the strong feature for Zig is the comp time, and during the compile time, you can do a lot of things. Desiree, we have to speed up. Okay. Almost there. Thank you. So the last one is exactly the cross compilation. The cross compilation, for using Zig, you can only use the Zig CLI, right? And then you can compile your code in Zig, or you can use Zig as a compiler to do the same thing with C++ or C code. So it's very good to use Zig to compile. So instead of using C or instead of using C++, you can only use Zig to compile in Zig, C, and also C++. Or even coexist. Maybe you can have like a project where you can use Zig and C++ coexisting together. So you can do it, and it's easy. In a simple command line, you can do a lot of things. And here, for example, is the example which I mentioned before. You can, for sure, if you want to understand better, the case for Uber, right? So Uber had a hard environment, which they have a lot of tree hosts, like in Linux or Mac OS, different. And then you have like a different target, right? So it means that you are building, compile your application in your target, in your host, and then where you execute is a different host. So using Zig, they could move from the biggest infrastructure, right, to a single tree archive, and then manage in a better way. So the summary is, with Zig is very early, right? It's very early to claim to be a success or to replace the C. We need to wait much more, wait much more the stable version, or see how the things will really work. But what is really promised that you can use right now is a Zig as during the compilation, right? During the cross-compile, and also build the system build. So the 3 points here is Zig is very strong in the interoperability with C and C++. The cross-compilation and build the system is very interesting and much more promising. And also during the compile time, you can do a lot of things. But let's talk about the Carbon.
Yeah, and this is going to be quicker, don't worry, because the most interesting about Carbon is Well, it was first introduced by Chandler Carruth last year, actually, to a wider audience at the C++ North conference. It's backed by Google, so Google's paying a few of the developers to push this forward. And just to set the expectations right away, it's experimental. Like there's no compiler, no tool chain, and even for the language specification, they said 2024, maybe 2025, we don't know. So we are years from using Carbon in a production way. However, I put this. This is the GitHub chart of the commits. So the whole language evolves in GitHub, and you can follow it. There's stuff going on, and right, people are investing money in this. And what I find while we put Carbon in. It's supposed to be a true successor of C++, not an alternative as we see with Zig and Rust, but similar what we have from from JavaScript to TypeScript, from Java to Kotlin. Carbon is supposed to be the successor of C++. And since there's not much there to test, we can just ask, like, we can't assume, like, how is the performance of C++? But we can look very briefly at the concepts, because if you want to be a successor for C++, you need to have a seamless bidirectional operability, and you should support the C++ developers. It should be a good learning curve, certain concepts and idiomism of C++ should be applicable, and you want to have a nice migration. And if I want to have this operability, I can do two things. I can make a subset of C++, like modern C++, or I can have a superset, everything that C++ has, I can do this, with Carbon as well. They are going a different path, because they say, oh, we're going to build something next to it and just bind everything there is, every data type, every concept, together with what C++ says, which means it's somewhat of a do or die thing. It either works or it doesn't work. But what it's also interesting to be able to have this, calls Carbon from C++ and the other way around. There needs to be lots of stuff going on under the hood. You need to generate Carbon code, and you need to generate C++ code, and likely you're going to need the C++ 20 standard for this. So that's going to be a challenge. And also what's worth highlighting, if you want, they claim, oh, we want to have more memory safety by default. You can still mess up things, but we want to have this by default. You're going to break the standard library interface. And you're going to break how you're handling reference pointers right now, and how you're handling, the pointers if you're not using smart pointers. So even in the talk, which I put there below, it won't be like, oh, now you're using Carbon, and with all the features. Likely, you will have your unsafe C++ code, and then you basically make unsafe Carbon code out of that, and then you have, then you can tweak it and have safe Carbon code. So I'm not skeptical, but I'm like, I'm not hyped right now. So, because I think it's too early to say if Carbon really can become a successor, especially since lots of the critical things in the language are not fully decided yet. It's unclear if it will ever, develop this ecosystem we see right now with Rust or other languages. Sorry, it's still on. It feels like it's for the people who don't want to switch from C++. So let's see. We got 30 seconds for the summary.
Okay, I'll be quick. So in terms of hype, hope, and hell, right, for sure we can use the tech radar as a template for us to reflect. But if you're thinking about the Rust, for sure, in terms of adoptions, we have like much more what is promised. It's a promised language. And also the ecosystem is much more matured. And when you're talking about Zig is still in development, right? It's for sure, it's very interesting as a tool chain, but it's still in development. And when you're talking about Carbon, it's much more experimental phase. So you can have like this tree in this way to understand and decide for yourself what's hype, hope, and hell. So thank you so much.
Thank you.